Hi, welcome to everyone's favourite segment, Mailbag. Yes, I'm still inundated with mailbag stuff. I've got 15 items and I'm not going to be able to get through them all. And that actually brings me to comments on last week's mailbag. It was only like 19 or 20 minutes long. People said it wasn't long enough. And well, yeah, fair enough. I only opened like 4 items or something like that. So this one will be a bit longer. Heck, people tell me to make longer videos. Okay, no worries. And also there were quite a few comments on the previous video that I should possibly spend more time opening mail and less time actually doing teardowns and things like that. People said they really wanted me to go in depth on the teardowns and actually keep them as a separate video. So, okay, let me know what you think specifically on that item. Usually my rule is that if I know it's just going to be quick, easy, and it's not hugely much involved inside the item, I'll tear it down on the mailbag, i.e. like it's under 5 minutes or something like that. But you'll notice that the calculator last time, for example, the big programmable scientific calculator, I save that for a separate teardown because I know it's going to be quite involved and possibly rather interesting inside, whereas something like the calculator, the Commodore calculator, yeah, I just tore that down because, well, I knew there wasn't going to be much in it. There was going to be the display, a chip, and not a huge amount extra. So anyway, let me know in the comments what you want me to do with that sort of stuff. Do you like me just opening the mail? In fact, you probably do, so I should stop bloody talking and open the mail. Everyone seems to love the knife, so geez, where do I start? I don't know. This big one looks interesting. This one just came in the other day, and this one just came in as well. I've got a few old ones here, so maybe I'll start with one of those. Before we get started, just some housekeeping. For those of you wondering about the video quality here and how I actually stand out, the background's a little bit fuzzy and how the image quality looks much different. I'm actually shooting this with my Sony Nex VG30 interchangeable lens camcorder with the built-in mic, by the way. It's 2 meters away, but it does a reasonable job of the audio, I think. Probably not as good if I'm mic'd up, but anyway, yeah, it really stands out in the background. So I really like this camera for these sort of talking headshots. It really works well, but I still prefer my Canon HF G30 and HF G10 for the product teardowns and stuff like that. But anyway, it's really quite good. I've got the I think it's the 18 to 50 zoom, fixed zoom lens on the thing, and yeah, the image quality is just absolutely stunning. I love it. So anyway, Spitzenfell, that name's familiar, from Germany. This one's been around for a while. It's almost empty. It's light. I don't know. So let's open it up. Hi to all my German viewers yet again. So, and yes, for those who are asking, this is the Crocodile Dundee knife, or pretty darn close to it. There you go. So let's open it up and see what we got. We have paper. There's got to be something in here. Newspaper. Ta-da! Anti-static bag with a note. Greetings from the land where the sun... Way! A little board popped out with a schematic. Hi Dave, find attached a little board used for driving 12-volt LED strips. The 2 pots, shitty brand, adjust brightness and fading delay on the AT Tiny 13. Can also receive commands via the serial at 9K board. There you go. So that looks pretty cute. Let's take a closer look. So there you go. Look at that, covered in some clear heat shrink with a cutout on it for the 2 pots there. So there's your AT Tiny, and yes, it is open source hardware. So Robert's released those on the website. I'll link that in down below. Love the little smiley face there. And we've got 12, very simple, 12 volts in, LED strip out, presumably like as many LEDs as the series string up to the voltage. Then we've got the in-circuit programming interface. Presumably that's also where the serial commands can go through as well. And there's nothing fancy doing here at all. We've got the AT Tiny. We've got a little SOC23 voltage regulator to generate the presumably 5, or does that work off 3.3? Anyway, for the microcontroller, we've got the in-system programming, and then we've got our N-channel MOSFET to, you know, the high current for the PWM for the LEDs, and that's just driven directly from pin on the micro. And then we've got the 2 inputs from the pots, and they're just going into ADC pins on the micros and reading that value. Incredibly simple. My only issue with this would be that the LED driver here is not a constant current. It's just a switch in a MOSFET off and on. So your current limiting has to be done in your LED strip. So it would have been nice if it had, you know, some programmable current limits on the board. You could have done that fairly easily around the MOSFET there. So yeah, that'd be a nice little addition. And then you could maybe set that with a couple of dip switches. The board, you know, would have to probably be a little bit bigger than that unless you went for a double-sided load or something like that. But that's what I'd add anyway. But maybe Robert is targeting a specific type of LED strip that he has in mind. And the other thing with this is, although the pin on this thing is designed to go to the positive input voltage over here, well, over here, VN, you don't necessarily have to be limited by that input voltage here, which is nominally 12 volts, but this MCP 1804 voltage regulator can actually go up to 28 volts. So in theory, as long as, well, the input cap there, as long as that, it should be, it's just a 100N ceramic, you know, probably rated at 50 volts. You should be able to get the full 28 volts input voltage here if you wanted to drive a LED string up to that full 28 volts. You could do so, no problems whatsoever. So I'm not sure why it's just limited to 12 volts at the input here. So, and then you're also limited by the voltage of the AO 3400 MOSFET, which in this case it's a 30 volt MOSFET. So pretty well matches the MCP 1804 here in that, you know, pretty much 0 to 28 volts input. You wouldn't have to worry about external excessive dissipation in here, because really all you're driving is a microcontroller, a bugger all current. So even at the full input voltage here, not a problem. Alright, what I've done here is just hacked one of these fluoro LED tube replacement things. This one had actually failed. I think I showed it in a previous video. And I've got 8 LEDs here. These are white ones, so these are going to have like a 3 volt drop each. So it's going to need 24 volts to actually power these. So that's within the limits of our little board here, if I'm right. So I've got that hooked up. I've got it in series with a 10 ohm load resistor here that I had lying around, and then I've got it hooked up to the power supply up here, and we're going to turn it on. I'm going to set like 100 milliamp current limit here, 16 volts start out. We probably should find that it's not going to light up, of course, because there's not enough voltage, but let's have a look at what voltage it actually starts up at. Right, 16 volts at the moment. We're drawing 7 milliamps or thereabouts, so, you know, it's not dissipating a huge amount of power, you know, 0.1 watts or whatever. Hey, bingo, there we go. Yeah, it's on. So that was about 19 volts. You can just see them on, and now you can really see them on there. And we can probably, let's turn it back down, and we can have a play around with those pots to see if we can get any effects. And yep, we can get in there and with these dicky pots, very trickily adjust the brightness there and the fade in delay as well. If we switch it on, you can see them fade in, and we can just tweak that maybe a little bit more. Man, I hate these pots. But yeah, we can set the fade in delay. So yep, it works. So thanks, Robert, and he has this available as an SMD kit, so the link will be down below. Next up, we have one from Andreas Zafiratos. Got that one wrong. He's from Germany as well. Oh, I get tons of stuff from Germany. By the way, sending stuff to... God, how do I open this? See, there's no visual clues on this at all. Sending stuff to Germany is absolutely awful. Customs sucks. My microcurrents are being delayed in some cases up to 2 months, and I've heard that, yeah, this is the way even inside the EU to Germany, this is the way stuff happens. So fed up with it. Tell you what, sending stuff to Germany, but thank you everyone who sends me stuff from Germany. Woo, what is this? Dating Bank Mega X. Like old gaming thing, I don't know, it just looks a bit gamey, I guess. Weird. It's like a metal box with a couple of headers on the back. Note time. Yes, Andreas has sent stuff in before to Sir David L. Jones. Thank you very much. Hello, it's me again, Andreas from Germany. I sent you this little PCB from one of my slot machines. The manufacturer is ADP Gürzelmann, Germany. Gürzelmann. This little PCB stores the gameplay and other stuff like clock, date. In the PCB there are 2 lithium cells which lose voltage at different ages, so you have to change it, otherwise the gameplay will be lost. ADP and other manufacturers put different tricks in it so you can't do it yourself or read out the data. That's what they think. If you open it the normal way, the gameplay will be lost. Okay, but this one's already had its gameplay lost, so that's alright. Can I figure out the 4 tricks how they detect an unauthorized opening handling? Good luck. The answers are on the back of this letter. Well, I won't cheat. Is it possible to open the case and change the batteries by yourself to trick the security circuits without losing the data? Thank you very much, Andreas. So, yeah, look, they've probably gone to a lot of trouble there. Has he had a crack at this? I think he's had a crack at opening this. Well, I'll tell you what, this is one of those classic things which I'm going to save, which people wanted me to save for a separate video. So I'll do a separate video on tamper-proof mechanisms for your products. How about that? Thanks, Andreas. Next up, this one comes from K. Vinerum from Norway. Hi to all my viewers in Norway, to the evil electronics video blog. Attention, Darth Jones. And it looks like we have a Norwegian bear stamp on it too. Sorry, I'm not going to show the stamps or the postcards up close these days, but I do read them and look at them, so thank you very much. Let's have a look what Kay has sent us. A whole bunch of goodies. We have paper tape, punched paper tape. Again, I've gotten some of that before, and it's a... Okay, yep. Let's go to the other camera. Hilsen fra Porsgrunn. Nice little town. Look at that. Beautiful. Thank you very much. That's Porsgrunn in Norway. Absolutely, totally pronouncing that incorrectly, as always. Look, it's been stapled. The paper tape has been stapled on here. Hi again, Dave. Here is a piece of refined silica from a solar panel factory. That is closed down here. Why is it closed down? That's a shame. Norway doesn't get the most amount of sun, does it? Maybe you can use it to show semiconductor basics in Fundamentals Friday. Okay, awesome. I also attached a shiny golden thing. No idea what it does. Again, please excuse the worn print ribbon on the teletype. And he's used the teletype. Just absolutely brilliant. And I believe this is the paper tape used to actually print this message out on the teletype. That's just nerd all over it. So we have a little 3D printed thingamabob. Not sure what that is. Yes, thingamabob is a technical term. And let's have a look. There's our gold. Hey, there we go. And look at that. It's refined silica. You know, just the rock silica. There are many different types of silica rock, as I believe it, but I didn't think that these were used in solar panel manufacturing. I thought they used sand, just like the semiconductor manufacturers use, but I don't know the ins and outs of that. If anyone wants to share it with us, then any info on that, then please do. But of course, you know, silicon is the second most abundant element in the Earth's crust, oxygen being the most abundant. So, you know, it's everywhere, and I believe that sand has the highest concentration of it, as opposed to this silica, you know, rock, I guess. So, anyway, that's rather interesting. If people have more details on that, please let us know. But doesn't that look just stunning? Oh, and there we go. There's a nice close-up of that, and that looks just beautiful. It really does.
It's very, very consistent and very pure. Not that I know jack all about, I'm not a rock person, as they call geologists, but yeah, that just looks beautiful. I wonder where they got this from. Did it actually come from Norway, locally? And it turns out that yes, Norway do have silicate mines that most likely this came from. I would presume that they would have got it locally. They wouldn't have imported it if they could actually process it actually mine it and process it themselves. So this looks like it's the raw silicate, and they basically goes through several stages there. If they want to just turn it into metallurgical grade silicate, which is used in all sorts of manufacturing processes, industrial applications, things like that, they pretty much, I believe, just remove the oxygen from it. But then if you want to actually put it into photovoltaic grade silicon, which is another like a whole bunch of chemical processes on top of that, which, geez, I won't go into because I don't understand it. And then if you want, then on top of that, they have the the really ultra pure stuff that they use in leading edge semiconductors. So the photovoltaic stuff sort of sits somewhere in quality between the metallurgical stuff and the stuff that's used in silicon chips. You can see the difference of what's actually inside this thing as opposed to the surface on it. And they would have, I don't know, used a diamond saw to cut this or something like that to shear it off into this piece here. But if anyone knows how exactly then they go from this to a particular solar panel, and then Jeetal, if I'm pronouncing his name correctly, which I'm sure I'm not, sorry, I'll just call you K. I think it's a silent K at the front. Anyway, wants to know what this thing is, and well, it's obviously some sort of photo sensor or something like that, because it's got the clear top on it. So let me see if I can hold that and get a better focus inside. Well, that is fascinating. Check out inside there. What is that? Offhand, I don't know. I wouldn't like to hazard a guess. But, yeah, I don't know. Anyone?
Next up, we've got Ali Verdond, I believe. He's from Belgium. Thank you very much, Ali. Let's take a look. Don't need the knife for this one. And we have some bubble wrap, a note, requisite ESD bag. Aha, looks like we have a little dev board with a breadboard. I always like these. I love the mini breadboards. Beautiful. Let's take a look. Hi Dave, I am Ali. I'm 16 and he lives in Brussels, Belgium. Awesome. Thank you very much. He likes Fundamentals Friday. It's his first production product, the Row board. I wanted to build a development board for robotic applications, so I built this board. I had some extra PCBs, so I decided to sell a bunch on Tindy. Awesome. Thank you very much, Ali. Let's take a look at the Row board. Here it is. Whoop. There we go, 3rd generation Row board, open source hardware, Deep Night Labs, nice name, I like it. And it's not bad at all. It's got a H bridge on here and basically a motor, a robot, as it says, a robotic development platform. You put your microcontroller on here, that's all you need for, you just need a breadboard of that size just to lash the thing up, get it working, and it's got the H bridge and the motor drive on it. Yeah, whack the power supply in and Bob's your uncle. And the only real issue I have with that, Ali, is that you've basically used all the same size traces running to the motor drive traces as you've used for the signal ones. So yeah, you want to use big fat traces going to your terminal blocks up here for your motor control, any high powered stuff, and looping from the power supply. You've flood filled your ground plane, everything's fine there, but just yeah, going off to the motor drive. I'm not sure what this thing's capable of. If it's only a couple hundred milliamps, then that's okay. But just as good practice, I would have put large thick power traces. You might run a 50 thou trace or something over there, or 100 thou trace, something like that. But yeah, that's neat. I like it. I'll add the link in down below to Tindy if people want to check it out. We're really churning through them now. We've got one from Australia. Australia. Beauty. This is from Wigman27. He's in Lithgow, up in the mountains. Beauty. Don't need the knife for this one either. Let's see what Wigman27 has sent. Gee. It's jammed in there. Here we go. It's a board. It requires a heatsink. Oh, it's a dummy load. We have a PSU dummy load. No doubt a lot of people are doing dummy loads nowadays. Ever since I started that incredibly simple dummy load I did with the FET. And people, this one looks fairly involved. Wow, this is a full electronic dummy load. And it's got some artwork on the PCB. Let's go.
G'day Dave, I spoke to you at Maker Faire about an open source dummy load project he's been working on, inspired, yes, by my constant current load. A bit of help from the forum members as well. Yes, there's tons of dummy load talk on the forums and everyone gets involved and it's really awesome. A lot of people are showcasing their dummy load designs on there and getting feedback and all sorts of things. It's fantastic. He sent me the schematic and a blank PCB. Sorry, it's blank, but I'm still working on a proper enclosure. No worries. And I guess you need I don't need another dummy load. I'm mainly after the feedback of the layout of the PCB. It's his second attempt. Rev A was his very first at a PCB. Awesome. Okay, second ever attempt. That's terrific. Tried to keep the noisy parts away from the sensors and try to keep parts together. Also done. And Instructable, which I'll link in down below. Thank you very much, Lee Wiggins. Let's take a look. First of all, let's take a look at the schematic, which, sorry, it's huge. It's an A3 one, but very neatly laid out and modular, complete with descriptive blocks around everything. That is a beautiful schematic. Fantastic. Uses the ATmega 32U4, so it's like a USB interface one. Does it actually? Yes, the USB's going in, so presumably remote upload and all that sort of jazz. And what else do you get? There's our USB. Got all the requisite protections around there. Fantastic. We've got ourselves the DAC, the MCP 4922. Let me zoom in here. That's ridiculous. And we've got it's LCD, so it's pretty fancy-pantsy. There's even motor control down here. Terrific. You've got your catch diode on there. Beautiful. Well done. And we've got ourselves a rotary encoder by the looks of it. And 5-volt auto USB selector between VIN and VUSB. Excellent. He's doing that with a relay. And there's our voltage reference. It's an analog devices part. And there's our ADC for the VIN to measure the battery voltage, presumably, and the current output as well. And yep, here's our basic current load. We've got an N-channel MOSFET, a bunch of parallel 1 ohm resistors here, 10 of them by the looks of that, to get 100 milliohms cheap and easily. That's a common technique to do, which I showed on one of my boards, and that's the DAC set. Yeah, we've got some compensation there, LM324. It's all looking quite good. And this part I like. Look at this. Dual temp sensors here under heatsink. And there we go. He's got the game with the calculations and everything. Absolutely fantastic. This is your first project. Oh, this is terrific. And check this out. There's the temperature sensors there mounted under the heatsink. So you whack the heatsink on there and then you solder it down, press fit in onto this surface mount temperature sensors. That is a novel little way to do it. The only issue I would have with that would be potential stress on the chips if they're actually compressed and there's a bit of movement in there because you're only mounting on the one axis. But when you're soldering down the heatsink onto there, it's going to be it's going to be pretty darn rock solid. So it's just like one of those in theory things. But love the little artwork there. Terrific. And let's have a look at the rest of the layout here. We've got ourselves our big power SMD power resistors down in here and huge big traces on there. I like that. No problems whatsoever. All going over and then just tapering down into the MOSFET pin down in there. Beautiful. Let's check the other side. Yep, there it is. Bam, straight back and then tapering down in. This is a beautiful layout. I Look at this. There's no problems whatsoever. Everything is sort of, there's no one, this trace isn't going all the way up around here and back to here. Routed, laid out sensibly. At first glance, I'm really liking the look of this. Look, everything's sort of short path together. That is a professional layout. It really is. Good on you, Lee. That is awesome. I can't believe that's your first PCB layout effort. It looks like you've been doing it for a long time. That is really well done. I'm impressed with that. I'm hard pressed to fault that. I don't know about the solder mask expansion on there. I might have to get my macro lens down in there. The only issue is you've put Con 1 under there, so you can't actually read it. It's going to be silkscreen's a bit hidden, but I'm nitpicking. You've got the ISCP there. You haven't marked pin 1 on the outside here. I would have just put a pin, but a pin 1 identifier there for your board interconnects. But geez, I'm nitpicking. I really am. In terms of layout, I'm having a hard time folding that thing at all. I mean, you flood filled everything. You've even got thermal relieves going in your vias there. There's no particular need to have thermal relieves on your vias going through that board, but it doesn't matter either way. It's just personal preference. That's fine. That's terrific. That's one of the best example layouts I've seen, especially if that's only your second board. Huge thumbs up. I don't know. Can anyone fault that? I'm having a hard time at first glance. Like I didn't look over it before hitting record here. This is my first impression of it, but yeah, I can't fault that at all. Everything's the way you're going to tell if it's good, everything's like laid out sensibly, nice, compact. There's not a lot of wasted space on here, really, not a huge amount. You got some around here, but that's a bit inevitable kind of thing. But it's really nice and compact. All your main circuitry around here, and your placement has been sensible, because I don't see any traces going willy-nilly, like I said, like looping back and going around and things like that. Just straight there, bang, straight into your, like you've put your micro right down. That's what I would have done. Of course, you put your LCD connector right on the edge like that, and you're going to put your micro close to that, because you're going to have all these, like this bus running over to this connector. So it'd be stupid to put like your chip up here or something like that, and then run your traces all the way over here after you've done that. It's just, so sensible placement. That's exactly how I would have placed things. Microcontroller, LCD is there for a reason in terms of case and wiring and things like that. Your microcontroller's near it. Then you've got your analog stuff between there and your driving MOSFET up here, which is exactly what you want. And yep, that's spot on. And yep, you haven't widened your solder mask expansion there. You've still got solder mask between pads on there. So that is absolutely bang on. I like it. So thank you very much, Lee, for sending that one in. I will post the links down below if anyone wants to check out this programmable dummy load, because, well, it looks like, a really nice project. Does exactly what you want. It's got microcontroller, LCD, rotor encoder to set the programmable current and display and measure and display the current. Looks like it's going to do the business really quite well. So that is a very nice application and implementation of a dummy load project. Big thumbs up. Next up, one from just Perkins. I don't know if that's a first name or a last name. From Gainesville in Florida. So let's check this out. We have another PCB. Excellent. It's an SMD proto board. Terrific. I love proto boards. Let's take a look at this one. Hey Dave, I'm an electrical engineer student at the University of Florida. I've been designing electronics since I was 6. I started off taking my toys apart to see how they worked. Awesome, didn't we all? I love it. I've been hooked ever since. This is an SMD prototyping board I designed. In KiCad I use it for prototyping new micros and such. I thought you might like to have a look, and if you have a use for it, information can be found at here, which of course I'll link in down below, and available on Tindy. Everyone's selling stuff on Tindy. It seems to be all the rage. Might have to try it myself. Adam Perkins, thank you very much, Adam. Let's take a look at this lovely proto board. Okay, first of all, here we have a 0.1 inch matrix with, it looks like, common positive and negative buses. They would be joined on the bottom side. Oh, I can't really see it here, but yeah, they'd be joined on the bottom side there. So we've got common buses, and that looks like a footprint for a tact switch, like a long tact switch. So I'm not sure these are other tact switches. A bit more labeling. Oh yeah, here we go, SMD tact switch on this side. We've got some caps, we've got some 6-pin SOT packages happening there, and so you can have you know, bypass caps and various other SMD caps and wire those over. So that's not bad at all. A bit more, maybe a little bit more detail on the silk screen would have been handy. And this is for SOICs, bringing them out to 0.1 inch headers here. So there you go. That's not too bad at all. You could fit quite a few SO packages on there. No dramas whatsoever. And then we've got this smaller pin pitch up here. So, yep, that's an SOP. And what else we got? More tact switches. He loves tact switches by the looks of it. And then we've got some more generic I/O up there. And then we've got our requisite 0.5mm pin pitch array here, which this is a sort of like a common staggered array to allow you to get different pin count and size packages and things like that. It works reasonably well, and they're all broken out to those 0.1 inch headers there, so that's really quite neat. We've got some USB, micro USB there, all mounted on, crystal mounted on, SOT23 6s on the back side there. Then we've got some power regulation stuff there, and on the other side as well, so different standard pin out power regulators. Very nice, of course, you need that sort of thing. No DC jack on here that I can see. Would have been nice to have a DC jack added to it, but still, this looks like a very useful proto board, worth having. You know, there's no such thing as the ideal proto board, it just doesn't exist. So it's worth having a whole selection of these different types of proto boards in your junk bin, just for any, you know, oddball project that comes up that you know, happens to be more suited to one type of proto board to the other. So this one looks like it's very useful indeed. And I think somebody's having a second suck at the Sav. Geppetto Electronics, which we've seen before. Just got electronic parts in here. Don't really need the knife for this one. There we go. My bare hands, my bare nerdy hands. We have a board fully built, plus more parts. Hey, lots of little boards today. Beauty. Oops, I've been pronouncing it wrong. It's a soft G. Geppetto, like Pinocchio's maker. Thank you very much. Anyway, I'm sending you a thing I call the Pi Power. It's the power supply that the Raspberry Pi should have come with. Have we seen this before? I think we've, no, maybe, I don't know. Pi Power, I can't remember. Too many mailbags, too many videos, oh goodness. Standard 2.1mm barrel connector for input power, and will accept anywhere from 6 to 15 volts, will output up to 2 volts at 5 amps. In my test, ripple on the output is newer than, oh no, I think I saw this on maybe the forum. Maybe it was talked about on the forum, that's where I've seen it. Open hardware project, it's fairly simple schematics on my blog. I would have loved but wanted to design for 2 amps. Oh yeah, you're not going to use a 34063. They're not the greatest device, they're pretty piss poor actually. And there's a schematic for it. It's just a switch mode controller and with an external MOSFET on it, external P-channel MOSFET, and that's it. So let's take our Raspberry Pi here, and here's our board. It's got an extended header like that, so it's designed to plug into the Raspberry Pi. Now here's one thing, I don't know whether or not it plugs in that direction or that direction. I'm assuming just based on the orientation of the power connector, it makes sense for it to, and not overhanging the board, it makes sense for it to be plugged in that way. But what happens if people do actually plug it in backwards? Oops. I'm not actually sure what happens there. You know, Raspberry Pi fans probably know the pin out off the top of their head, but there's nothing to stop you plugging that in backwards. And I just checked his Tindy store, and sure enough, yes, it does go on that way and plugs in like that. Kind of makes sense, I guess. So there you go, and it's only 15 bucks on the Tindy store. Everyone, man, his dog's using Tindy. Jeez, I'm going to check this out. Really? Anyway, thank you very much. I don't know your name. Sorry, you don't put your name. Dear Mr. Geppetto. That must be it. I'm still probably pronouncing it crap. Everyone's laughing at me. I'll go away now. Open another envelope. Thank you very much. The Pi Power. Neat.
Whew, this is starting to get towards a mega Mailbag Monday or a monster Mailbag Monday or whatever M you want to choose it. Michael Bays, I think, B-A-A-S-E. He's from Zynick in Germany. Another German one. Thank you very much. Yeah, it's got various items in here. I don't think there's just one thing in this puppy. So let's open her up. Let's have a look. Ooh, looks like we've got some old stuff. That looks interesting. We have, in a pouch with an oscilloscope probe, it looks like a pocket oscilloscope, and something rattly in a box, and a bunch of paperwork, and a postcard from Havelstadt, Zynick in Germany. Thank you very much. This is some stuff I have double. So have fun. Oh, okay, he's already got them. The Aussie is fully the Oz is fully functionality. In my current project, I use ZZ pies or 22 pies. I don't know of the 22 pieces of the 6004 centimeter because it's hard.
Aha, this is what he's talking about. The MCP 6001, he uses 22 of them. 1 meg low power op amp. Yeah, just like a sort of microchips, like a Jelly Bean kind of, low power op amp. These things only go to 6 volts, so most of I don't think actually Microchip make any op amps that go any higher than 6 volts. I think all their process geometry is all focused around, Target 3001 PCB package. Yes, Target 3001 is a German PCB package. I believe donkeys years ago, they used, this is way before the blog, they used my PCB design tutorial in their package or something. They asked me if they could use it, and I said, yeah, no worries. My electrical working on it. Okay, so there you go. You're working on your project. Awesome. Thank you very much. And there's the lovely postcard. Havelstadt, Zynick in Germany. And it looks like, if my German is any good, we have a 3-axis accelerometer, SPI and I2C. There we go. For those who love to read their German, go for your life. And it looks like we have that little board. There's the schematic. Looks like we have that in here somewhere, but we have ourselves a cheap-ass pocket oscilloscope made by who? I don't know. Don't know that symbol. No idea, but we have a pocket. We'll take a look at that in a minute. Let's check out the pocket. It looks like a DSO Nano, which I have. No, it's another one. eDesign, Creative Commons. There you go. MiniDSO.com. There you go. Offhand, I don't remember it. Maybe I have heard of it. Yes, I have the 4-channel DSO quad from Seed Studios, and here it is. And looks like there's not much between them. They're both in a nice solid metal die-cast case there. In fact, they're identical. So, yeah, it is actually a DSO quad. There you go. Yes. It's exactly the same. It's just labeled differently and sold under different brand. It's just rebadged. Now, I think I have shown the DSO quad. I've used it on the blog before. And if you haven't, here we go. Digital storage oscilloscope, hardware version, blah, blah, blah. I missed it. But yeah, like the thing is, the user interface is horrible up here, and how you have to scroll through things. I can't remember how to use it. And they got like play, stop, start buttons for like a, MP3 player case or whatever it was before. And it's just, no, it's just user interface fail. Yes, I do believe there is some third-party software, firmware you can get to install on this that makes it more usable. I haven't actually tried that myself yet. Now, I'm not sure what this is. It looks like some sort of radio kit or something. That's obviously a speaker, and I don't know, but look, hey, it is It is. It is a radio kit. Look, got ourselves a speaker and a pot, and yep, there's our ferrite and the AM radio. There you go. It's a classic AM radio kit. There's our variable capacitor for the tuning. It's got a knob and works off a single AA cell. Neat little kit. I'm not sure I'm that keen to build an AM radio though. For kids under 14, I guess. There you go. Frenzy's kit. Is this a kit maker or is that the... yeah, that's neat. I'll see if I can find a link for that one. Whoa, there's his project. That's why he needs 22 of those suckers. Look, I don't know what that is, but yep, there's a lot going on there. I think I might get this now. I think ELV is a German electronics magazine, is it? And this is potentially an article that, here it is. It's a little 3-axis board, SBI and I2C board. It looks like it's a project that I think Michael has possibly designed and written. I could be wrong because he doesn't really explain it, but I think that's what's going on here. Perhaps. Yeah, so I'm not sure if Michael is selling this or whatever. Perhaps he can clear it up in the comments, because it's a bit of eclectic mix of stuff he's sent in. Anyway, I'll include the link down below if you're interested in this little 3-axis breadboard board, which looks quite neat. It's looking, there's a matching USB to I2C adapter as well for that thing, so I'm sure the Germans know exactly what I'm talking about. And yeah, I'm just here a little bit bamboozled. So I'm not entirely sure what the purpose of all this is, Michael, but perhaps you'd like to clarify. But thank you for sending it in. That's an interesting little kit. I'm not sure. Maybe I can. Maybe that'll be like Sagan's first kit or something like that. You know, little AM radio, really big through-hole parts. He's a few years away from that sort of thing, I suspect. Well, at least a year or two away, probably. But yeah, these things, I don't know. What do you want me to do? Do a teardown of it? I don't think there's a huge amount. There's an ARM Cortex M3 processor in here and a bit of analog functionality. All these have been, you know, photographed and torn down on the by the community because it's an open source hardware design. I don't think there's terribly anything interesting in there. Anyway, I'll link it to this I2C accelerometer module. That might actually come in handy sometime. Thank you very much, Michael.
Next up, one from the old dart. Yes, England, Southampton, to be exact. Ben Patton. Thank you very much, Ben. And let's have a look. What's inside this puppy? I guess I can just rip that open. I think it's a... yeah, there we go. There's a note. What have we got? It's an organiser. It's a Scion. I recognise it a mile away. It's a Scion organiser 2.
Hi Dave, not sure if you've seen one of these before. Yes, I have. It's a Scion Organizer 2. I bought it at the early days of eBay and never known what to do with it until I watched this show in the working condition, but feel free to tear down as you wish. Unfortunately, Ben, I've already done a teardown of precisely this, a Scion Organizer 2. In fact, I did a history of PDA teardowns where it was a Palm Pilot and one of the early HP ones, and actually compared all three. So I'll actually link that in. So unfortunately, I've already done it. So thank you very much. But yeah, it's hard to miss stuff when I've done like 700 bloody videos or something. Even I forget what ones I've done, and I don't expect everyone to see them. So thank you very much, Ben. Don't suppose you could email me if you feature this? Well, you can obviously see it. I can probably send you an email, but I'll likely forget. Goodness. Thank you very much, Ben.
Next one, a big padded envelope with, well, not much in it, just a tiny little thing at the end. Again, it's from the old dart, and it is from person unknown. So let's open it up, see what we got. Oh, I didn't get through the bubble wrap.
Oh, goodness. There we go. That's better. Oh, beautiful. What do we got? We've got a little box. We've got a little box. What's in our little box? I hope you can see this. I hope you don't mind. You know, there's not a huge amount of detail. It's not the same as when I used to open things like like standing behind the camera and the camera's looking here. It's not the same amount of detail, but everyone tells me that they prefer this talking head, bench shot with the rack stuff behind me. So let me know. Anyway, it's from Dean Chappell, and I won't show you his business card. He may not want me to do that. But Dean, what do we got here? What do we got? We've got a OLED screen. Beautiful. That is the one that I believe for the mailbag that I got the other week. That digital radio that had, the really dodgy flat flex on it that had been repaired. It was absolutely horrid. So I believe that's what it's for. Whoa. And yes, it is. It's an OLED display to replace the damaged Evoke Flow one. Pull off the knobs on the front panel, blah, blah, blah. We'll do that in a minute. It's fairly simple. I'm going to do that right now. So check out Dean's website, pure.com. That's not an Australian website. It's just got the /au on the end because, well, you don't want to speak English, do you? You want to speak Strine. No worries. And here it is. And, hey, that's an interesting... And backing on that, check that out. They've got a interesting pattern on there. Anyway, a replacement OLED display, absolutely brilliant. So I hope that works and does the business. Let's get the radio on, see if we can retrofit it. Awesome, Dean, thanks. So here's the radio. If you haven't seen it, the Evoke Flow, it's got a dodgy foot on it. It's got one missing foot. We can fix that easy. And yeah, inside the... OLED display was broken. So let's get back into this thing and see if we can replace it. Now I'm not sure why Dean mentions taking out off the front knobs to get access to the rotary encoders and the display. This one's actually screwed in with 4 screws on the back. I just took those off and it looks like the LCD is just going to pop out like that. So all we have to do is get that flat flex. Ta-da! We're out. So I just peeled off the protective film on that, and that just sits in there. It did have like some glue in there. I don't think I'll bother because I think it will press fit nicely against the front panel, and it's just fed back through there. Too easy. So that is going to go back in there very nicely. Just push the clip back into place, which holds it in. And Bob's your uncle. Let's power this thing up. All right, let's plug it in. It's got a 6-volt plug pack here. By the way, if you don't know what this is, it's a Wi-Fi radio with an OLED screen. And, okay, we're in. Let's get the capacitive to Evoke Flow. Woohoo! It works. Thank you very much, Dean. He says, well, I presume the rest of it's going to work. It's taking us time to boot. Bloody modern operating systems and crap. I don't know what it's running, but geez. It's taking us time for a radio setup network. All right. Meanwhile, check out the LCD that was in there. Look at this. Somebody has tried to repair the individual traces there on that flat flex, and it's just, no, it's just an absolute fail. And yeah, that's just like, and it's got a big... Looks like there's a big puncher hole in there or something. Don't know what's going on there. Maybe one of those traces is broken as well. But what a hack job! Look at that. That is awful. And it just verified the password. It's configuring. Please wait. And we're in. We're in like Flynn. I have no idea how to use this thing. Choose. Okay, so I can actually stream from the computer because that's my computer. So I can stream, well, I don't have any music on there. I don't listen to music here in the lab. And I can search artist name. Right, okay. So I thought it was a Wi-Fi radio, though. I thought you could get, like, radio stations. Maybe you can. I don't know. Haven't played with it yet. Can we actually get, like, a internet radio on the thing. Anyway, it works. So awesome. Thanks, Dean. All I've got to do is read RTFM, I guess. Media player settings. There we go. There's the main menu. It's got a DAB radio in it, the newfangled digital radio thing. I don't know. I've never heard digital radio. The lounge. Don't know what the lounge is. Hey, hello. Why do you keep going back? I'm not sure. It does have an FM radio, and it's supposed to be like a really good internet radio player and an aux input. So I'm not sure. Let's go into the lounge. Connect in. Maybe this is the internet radio thing. Wonder if I can get the amp hour on here. If not, how do we get it on there? Thelounge.com registration code. Sounds like a commercial website. Whoa, new version of firmware available. Should I? Yep, tap to upgrade. Anyway, I won't bore you with the details of all this, using this stuff. I'll have to RTFM. I did join that lounge thing. Yeah, you got to join and you can top up your account and pay for all sorts of stuff. I don't know. All I want to hear is the bloody amp hour on this thing. I'll figure it out, I'm sure.